All right, 6-7 deals with kind of a probability theory aspect, so it's kind of thrown in there at the very end. And of these chapters, this last two deals with some probability, and so that's what we're going to be looking at right now. So 6-7 deals with what's called permutation and combination, and so we're going to look at where we can use these, and it deals with trying to find how many possible situations there can be. And so let's say you want to do this. There's 4 places you want to visit. Okay, you could pick any 4 places, any 4 places in the world. You know, you could pick, New York City and Paris and France and Moscow and any of these beautiful places. Rio de Janeiro, Beijing, Tokyo, all those. Okay, just pick 4. And after you pick your 4, what you should try to do is try to list all possible paths that you can take to all 4 places. So, like, if you want to take, let's say, place A, B, C, okay, one path could be A, B, C, D. The next path would be A, B, D, C. Okay, as you see, it's a different way of visiting those 4 places. So try to list all 4 of them, and then after that, make as many possible lists using only 3 of them, but use all 4. And then make a list using 2 of the cities at a time, and then 1 city, and see how many you get. Okay, so if you want to do that right now, you can pause the video. I can wait. Got it? Great. So these were mine. So I picked Portland, San Diego, Madison, and Hickory. So California, Oregon, Wisconsin, and North Carolina, respectively. And so then I've listed it out. And I use just the first letter of each one to show it. So as you see with the 4 cities, we've got a lot. But if you look at when we pick 3 cities, it's the exact same number, which is kind of interesting to think. Oh, if I pick the 4 cities or if I pick the 3 cities, there's the same number of ways of me doing this. And then the 2 cities, you get half from the other ones. And then when you pick 1 city, you only have 4. Because it's like, hey, you can only go to 1 city. Well, how many cities are there for? Well, obviously there's going to be 4. And so what we're going to be looking at, permutation combination, is a way of figuring these out without actually writing out every single possible one that's out there. It's kind of a pain. So the first one is a permutation. And a permutation deals with the order in which the objects are set. So like the one that we just had. Okay. If you took those 4 cities, that is a permutation. Now, what you're going to be using is something called a factorial in this case, which is this exclamation point. Okay, it's not n, it's n factorial. Okay, you're not like excited about it. Well, you should be, because factorials are kind of cool. But anyway, so 4 factorial is the same as saying 4 times 3 times 2 times 1. So you multiply all the numbers from that number lower. So 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. Multiply it all together. And as you see, you get numbers. Your numbers get larger and larger and larger and larger and larger. Now, if you have a TI 83 or 84, the largest number you can do on your calculator is 69 factorial. You can't do 70. It comes up as an overflow. If you want to check that right now, you can. It's kind of cool, isn't it? Right. So 69 factorial is the largest one that you can do. And kind of the way to find where that factorial is you can look under the catalog, and then you just go to the very bottom, and it should be there. Or you can just multiply them all together. But anyway, so that's a permutation. So a permutation, the order matters. Now here is the actual permutation formula. NP R. Okay. N is always the larger number. R is the smaller number. And what you'll do is that you'll go n factorial all over n minus r factorial. Now you do not distribute this factorial. You do the subtraction first, and then you do the factorial of it. Okay? And what this example would be saying would be, okay, I've got 7 books on my shelf. How many ways can I order 4 of them? Okay, if I were to just take 4 and put them in order, how many different orders can I make? And that's what you're doing here. And so if you calculate this one, it would be 7 factorial all over 7 minus 4 is 3 factorial, which ends up being about 7 times 6 times 5 times 4 multiplied together. And so you get that multiplied through, and you get about 840. So there's 840 ways of organizing 4 books if you have 7 originally. Okay, and so permutation, the order matters. Okay, order matters. That's the key. Okay, a baseball team has 15 players. How many batting orders of 9 players can the manager create? Okay, not worrying about positions or anything. You could think this is like a high school team where everybody can play any position, or a senior league softball league. Okay, so how would we set this up? Well, we have a permutation. What's our bigger number? 15. 15 is bigger than 9. So it's going to be permutation of 15 and then 9. Now, when we plug it into our formula, we would have 15 factorial all over 15 minus 9 factorial, and then you could calculate it the rest of the way through. Okay, use your calculator to find this. The permutation button, again, if you go to catalog and then you go up, it should go to the bottom, and you should be able to find it. All right, and so as you see, there's 3,600 different batting orders that can be created with these 15 players. Okay. So a permutation is nice because you're able to take something that would take forever to write out every single one, and you can just go, hey, I just have to plug it into this formula. Sweet. All right, let's do another one. So in the 100-meter dash, 8 men start the race. Okay, and usually 8 men finish. Sometimes, I guess, if somebody says, no, I refuse, but okay, only 3 get a medal. Top 3, obviously, gold, silver, and bronze. How many different combinations of 1, 2, 3 can there be in the race? So it would be another permutation because our order matters, 1, 2, 3. And how many total do we have? 8. 8 is the biggest number, not 3. 100 doesn't matter. So it'd be 8 permutation, and how many positions are there? 3. So it'd be 8p3. And so then we would plug it into our formula, calculate it through, which it looks like it would be about 336 different combinations, okay, of finishing first, second, or third in a race. Okay. Now, let's say order doesn't matter. So you just want to get groups, okay? It doesn't matter who's first, who's second, who's last. All you want is a group. This is what you would use a combination. So a combination, the order does not matter. All you're looking at is a group. Okay, so a combination is slightly different than a permutation. If you remember, the permutation formula is n factorial all over n minus r factorial. So as you see, the only big difference is that you multiply it by r factorial on the bottom. So you have NCR, blah, blah, blah. 17C5 would look like this, 17 factorial over 5 factorial times 17 minus 5 factorial, which gets you about 6,188. A combination will be equal to or less than the permutation. Okay, your combination should never be a larger number than the permutation of the same numbers. Okay. All right, so here's an example where you can use a combination. So the National Security Council at the United Nations has 15 members. If they want to create a subcommittee, okay, of 7 members out of those 15, how many different subcommittees could be created from those 15 nations? And so since we're using a combination, it'd be 15 combo 7 combo. And we would plug this in. It would be 15 factorial all over 7 factorial times 15 minus 7 factorial. And then we would plug it in and solve it the rest of the way through. And the number of committees that are possible is 6,435. Different committees could be created from those 15 council members. Okay? So combination order does not matter. A permutation order matters. So the hardest thing here is identifying which is which. Your IRAT for this one. Your IRAT for this one, Eddie has 12 songs on his Walkman. He wants to select 8 to put them on an 8-track. How many different groups can be created? The second one, now he wants to know how many different playlists of those 12 songs can he put on his 8-track. An 8-track only has 8 tracks. Get the name? Okay. That's your IRAT for this one. Okay. So solve those, get those, and then we'll be good. Permutation combination.